Taking a look at number 27 here, we are to find the square root. Notice there's a negative sign underneath the radical. That definitely causes trouble. This radical sign says what times itself will give you this number, and if you multiply a number by itself, you can't get a negative number, at least if you multiply a real number by itself. So the way you handle this is you would simply say no solution. Alright, and technically there is no solution in the real numbers. Double bar R is a symbol for real numbers. Because there are solutions in what's called imaginary numbers, and we don't cover imaginary numbers in this course, so you're not going to have to worry about it yet. When you get to MAT 1033, you'll have to deal with imaginary numbers. Okay. I've also seen as a possible answer, well, I'll just put it right here, or not a real number. Alright, either of these is, they're saying the same thing, essentially. Okay, for our negative 256, let's look at our next one here. This negative sign's outside the radical, so that's okay. We'll just have to keep up with it. And for the square root of 256, it's rather large. You might not know that offhand, but I encourage you to just pay attention to the ones column, because this can give you a clue as to what the solution may be. Well, I'll just go ahead and cover this. If it was 1 times 1 would end in a 1, 2 times 2 would end in a 4, 3 times 3 a 9, 4 times 4 would end in a 6, right? Because 4 times 4 is 16, so it ends in a 6. That means, I think I'll scoot this over a little. If I had 14 times 14, that would end in a 6 as well. I think I'll back out a tiny bit here. So this would be, whatever it is, it ends in a 6, okay? And it happens to be 256. Wait a minute. 15 times 15 is 225. Yeah, so this one, it won't be, it's 196. 196, okay? And even if you're not doing this in your head, you just multiply 14 times 14. You'll find that it's 196. But the key here is that it ends in a 6, right? And if I had 24 times 24, that's going to be way too big for 256. Okay? So give up on something that ends in a 4. If it ends in a 5, this would end in a 5. If it ends in a 6, 6 times 6 is 36, right? 6 times 6 is 36. It ends in a 6. So 16 times 16 is our 256. Okay, again, you're just paying attention to the ones place can help give you a clue as to what the solution might be. So the square root of 256 is 16, and this negative sign, you just have to keep up with it, okay? So that would be your answer. For the next one, number 29, if you have, I mean, there's different ways to think of it, but in this case, the square root of 1 is 1, and the square root of 25 is 5. So without much trouble, you can generate the answer to that one. Okay. And then for number 30, I'll just do it real quick. The square root of 121 is 11, and the square root of 441, it's going to have to be over 20, right? because 20 times 20 would be 400. It's actually 21 times 21. Alright, so that takes care of number 30. And we'll turn our attention to number 31. And perhaps I'll zoom in a little bit here. Okay, they want the square root of 1 44 hundredths, or 1.44. If you have, let me zoom in again just so in case people can't really see that decimal point. If you have a decimal point, it might be hard to think in terms of square root while you're also trying to keep up with that decimal point. So initially just ignore it. The square root of 144 is 12. Okay, 12 times 12 is 144. And if you had 0.12, or 12 hundredths, when you multiply, you're going to end up with, let me just show you what happens here real quick. And this one's not going to work, but if you had 0.12 times 0.12, you would get 144. And then because you have 1, 2, 3, 4 digits behind the decimal, you would end up with 0.0144. So that's not what we're trying to get, okay? But if you had 1.2 times 1.2, you'll get your 144, and then you'll only have 2 digits behind the decimal. So you will get the 1.44, okay? So the square root of this is 1.2. So that would be your answer. Taking a look at number 32 here. 16 is a perfect square and x to the 8th is a perfect square. The square root of 16 is 4. The square root of x to the 8th is x to the 4th. And you can check that because 4 times 4 gives you 16. X to the 4th times x to the 4th. When you multiply, you add exponents. That would give you x to the 8th. Okay? Then we'll look at number 34. This 112 is not a perfect square. So you just list your 112 and start listing all the factors and keep your eye out for a perfect square somewhere lurking within that. Okay? So we would have, obviously 1 times 112 isn't going to help. So I'll start with 2 times 56. Still no perfect square. 3 won't go into it. 4, half of 56 would be 28. Okay, 4 is a perfect square. And 28 is made up of 4 times 7. So I could actually rewrite this 112 as 4. See if I can emphasize this. 28, all right? That is 4 times 7, right? So 4 times 4 times 7. Okay, it turns out that 16 times 7 is 112. I shouldn't have used the word and. 16 times 7 is 112. But using this method, we didn't get to our 16 yet. If we had kept going, we would have gotten there. But this is just as good a way of figuring out your solution. And let's get a little scratch paper here. Oh, well, actually, I'll just keep going. To get out from under the radical, you need a perfect square or 2 of a kind. So I'm just going to say that I have 2 of a kind. So that means a 4 gets out, and this 7 is stuck under the radical. So this would be the answer to number 34. If that's not real clear, 4 times 4 would give you a 16, and the square root of 16 is 4. So you're just going to have to get used to seeing different ways to find the square root. And let's see, we'll also take a look at number 38. And that gives us, here it's probably going to be helpful to rewrite this. Let me see. I can take the square root of 25. 63, I can't really take the square root of that, at least directly. All right, let's see here. 63 can be written as 3 times 21. That won't help us. What I'm thinking is 7 times 9 is 63. And notice that 9 is a perfect square. Okay, so I'm going to rewrite 63 as 9 times 7. Okay, and all this is still under the radical sign. 25 is a perfect square, so I'll just leave that as it is. Okay, and now, so that's equal. Okay, the square root of 9, I guess I'll go sideways here, is 3. This 7 is trapped underneath the radical sign. Okay, the square root of 25 is 5, and so for the denominator there's nothing trapped under the radical. Alright, so the solution would look like this. Some textbooks, let me kind of look in the other direction here. Some textbooks will go through the trouble of rewriting this entire expression as the square root of 63 over the square root of 25. And if it helps you to see more clearly what you're dealing with in that fashion, then that's fine. I just choose to keep it under one radical sign. And then let's see, number 40. We've got another situation where this is going to crop up. 15 is made up of 3 times 5, so we're not going to be able to get anything out of that. X to the 4th is a perfect square. Okay, so the square root of x to the 4th is x squared, but this 15 is still trapped under the radical, so you'll have square root of 15 up in your numerator. Okay, and I think we'll pause it there.